Okay, section 9.3, we're solving quadratic equations. Now we've already graphed in 9.1 and 9.2, so we've graphed the parabola, which represents the infinite number of solutions for a quadratic function. Now we're going to solve a quadratic equation, which means we have an equal sign, and we're setting it equal to something specific. What we do here is we set our ax squared plus bx plus c equal to 0. So we're looking for the value of x when y equals 0. It's a very specific solution we're looking for. It is the x-intercept or intercepts. The quadratic equation, the equations we'll be working on, can have 1, 2, or no x-intercepts. Okay? So for our purposes, when we talk about these specific solutions, we're going to call them zeros. Again, we call them zeros because it's when y equals 0. It's when it's the x-intercept. So you can see here, we could have 2 x-intercepts. Our parabola could have 1 x-intercept. Or we may have no x-intercepts. Those are the 3 options we're going to be running into as we're trying to solve or find these zeros for our quadratic equations. So we can solve these by either graphing, which we've already done. We graphed and we said, when we graph for linear equations, for example, what if our intercepts, or what if for our quadratic, our zeros are off my graph? What if I can't read the solution because it's not on the crosshairs? So there's reasons we want to solve these other than graphing. We want to solve them in a different way, so we solve them algebraically. And for section 9.3, we're going to use square roots. We can solve a quadratic using square roots when b equals 0. So here's an example. 3x squared minus 75 equals 0. All right, so what does that mean? Means I want to know what value of x or values of x are going to give me a 0 value for y, are going to equal 0. So I say solve, isolate, get a coefficient of 1, and I also need an exponent of 1. So I'm going to isolate first, add 75 to both sides, get 3x squared equals 75. Isolate my variable is done. Now get a coefficient of 1, divide by 3. I get x squared equals 25. I now have a coefficient of 1. But now I have to get an exponent of 1 also, because I don't want to solve for x squared, I want to solve for x. So I have to take the square root of both sides. Now notice this little asterisk here, and it says don't forget this, right? X squared equals 25. X can be either positive 5 or negative 5. When we go back to our square roots, when we're asked for the square root of 64, we find the natural root, which is just positive 8. But if x is in there, if it's a variable, we have to remember that x squared equals 64. X could either be positive 8 or negative 8. So that's why when we take the square root of both sides, when we're solving for a quadratic, solving for an x squared, we want to remember to take the positive or negative of that square root value on the right side. Okay, there's more examples of this in your book, section 9.3. Good luck on your homework.